that this session will be recorded, and so if you want to watch it again at a later date, you're welcome to do that or send it to someone else. Okay, again, this is Julie Bond with the Center for Urban Transportation Research, and I'd like to introduce today's speaker, Sean Barbeau. So a little bit about Sean. Dr. Sean Barbeau is the Principal Mobile Software Architect for R&D at the Center for Urban Transportation Research here at the University of South Florida in Tampa. He has served as the PI for multiple research projects investigating intelligent software systems for mobile phones. He has over 40 peer-reviewed papers and conference presentations and was a member of an international expert group which developed a Java-based software standard for location-aware mobile phones. Dr. Barbeau has 9 patented inventions and another 8 patents pending in the area of location-aware technology. He holds a BS and MS in computer science from USF, as well as a PhD in computer science and engineering from USF. So with that, I'm going to turn the time over to you, Sean.
Great. Thanks, Julie. So in today's webcast, I'm going to be talking about a project, the OneBusAway multi-region project. This is a project that the OneBusAway community as a whole has been working on. So there's many other contributors that makes what I'm going to be talking about today possible. The project was looking at rapidly expanding mobile transit apps to new cities. The other university partners that have been working in the OneBusAway community and on this particular effort are the University of Washington and Georgia Tech. And as I mentioned, there's many other both individual contributors and others that are part of the OneBusAway community that makes this possible. So just a little background here. Why do we want real-time information and why do we want to make that information available to transit riders? There have been several studies that have shown that the real-time transit information has direct benefits to the rider. This includes a shorter perceived wait time. So the rider, if they have access to real-time information, they think they're waiting a shorter amount of time than if they don't have access to real-time information. It's been shown they have a shorter actual wait time as well, which means that the actual physical amount of time they spend waiting for the bus stop is reduced. And that's because if they have information that they have, say, 10 minutes until their bus shows up, they can run and grab a cup of coffee or multitask and do something else and spend less idle time just wasted, not really knowing what's going on. It's also been shown that it lowers the learning curve for new riders. There's some work going on right now that we may be seeing increased ridership as well, and we hope to see some results of this research soon. Also, an increased feeling of safety at night, for example, at night, and there's been a few, it's shown up in a few studies as well. So, and we also know from some of the same research that riders prefer accessing real-time transit information via mobile apps as opposed to accessing that same information through a desktop or another interface. So the challenge here is that developing a custom mobile app is very expensive. So if an agency wants to, say, create a new application from scratch, some estimates place a fairly sophisticated mobile app that's accessing real-time information and then frequently updating. The development costs would be upwards of $150,000 for a single platform. So that, for example, would be just iOS, just the iPhone. That wouldn't include a separate application for Android or Windows phone. It also doesn't include the ongoing maintenance cost. So every time there's a new platform release, there's typically some changes that happen on the different mobile devices, and as a result, modifications need to be made to the application, and there's some ongoing costs associated with that. So as a result, both implementing and maintaining custom apps on all smartphone platforms is really cost prohibitive for transit agencies to do. And typically, the agencies just don't have this type of expertise in-house, and contracting for this just adds up really quickly and just isn't within the budgets of most transit agencies these days. So open data is good. Open data is when a transit agency opens up their schedule and real-time information to third-party developers to build transit applications. So These are unaffiliated developers that may, in their spare time, put together an application, or there are a few companies and organizations that provide applications to transit agencies that share their data. So sharing data is good, and that really enables an ecosystem, including the OneBusAway software that we're going to be I'm going to talk a little more about today. But this doesn't always result in apps by third-party developers. There's some cities where where apps work, third-party apps work really well. And an example is San Francisco, where you have a lot of high-tech professionals that are riding transit to work and have the skill set to build something that both helps themselves and other transit riders. But other cities just don't have that type of demographic riding public transportation, and as a result, you typically don't see as many third-party apps popping up in those cities, or at least by independent developers. So the question that we were looking at and interested in was, how can we cost-effectively launch mobile transit apps in new cities to give transit riders the same benefits that we discussed earlier, that certain transit riders in other cities see. So the OneBusAway project is something that we started working with a few years ago. This was originally developed at the University of Washington, and it's unique because it's an open source real-time transit information system, which means the software is completely open. The source code is open for anyone to download and modify and deploy in their own area. And this came out of the doctoral work of Brian Ferris and Kerry Watkins when they were both at the University of Washington. And the motivation behind this was to build a set of transit tools which made it easier for riders to use public transportation. And along with that, this also enabled research studies to understand how this information affects riders and how it could benefit them. And several of the research studies that I cited earlier in this presentation actually came out of the work of Brian and Kerry and some of their other, especially Kerry's students. Kerry is now a professor at Georgia Tech. So OneBusAway includes both server-side software. So this is software that can process real-time transit information, so a dump of say where all the buses are or how long it's going to take for the buses to arrive at particular bus stops, the type of information that's typically generated by an automated vehicle location system. And it can process that, and as well as the scheduled transit information, which is typically in the general transit feed specification or GTFS format. And it transforms that into a set of data that can easily be broken down into tinier bits for mobile apps to consume. And this is provided to the mobile apps via a application programming interface, or API. So this lets a mobile app ask, how long is it going to be till the next bus arrives at a particular stop? And then the OneBusAway software is able to respond and provide that information to an app. And the OneBusAway software suite includes mobile apps for iPhone, Android, Windows Phone, and Windows 8. And most of these came out of third-party developers, independent developers who saw the OneBusAway system being developed at UW and then wanted to develop apps for their own platform. So kind of these came out of the open data movement where application developers wanted to build something that helped themselves and others. And then they were adopted into the OneBusAway software suite of applications. So what we see here are the different interfaces, just to show you at a glance what these look like for the different platforms. So again, this is really unique to have Android, iPhone, Windows Phone, and Windows 8 applications that are all open source and all connect and operate with the same set of server-side software, which is also open source. And these applications provide real-time information to riders of when their bus is going to arrive, and provide things like favorites, bookmarks, reminders of when your bus is going to show up. So a fairly sophisticated set of tools for transit riders to help them use the transit system. So OneBusAway provides all these tools that are there to be used freely in other places. As of 2012, the mobile apps were only available in Puget Sound by default. So the OneBusAway multi-region project was really looking to address the question of how do we expand these apps to new cities and do this in a way that's sustainable and cost-effective and makes it really easy to add new cities along the way. The image you see here is the design of the original OneBusAway mobile apps. These apps were all by default pointed to the original OneBusAway system, which was maintained at the University of Washington. So when you started up the mobile apps on the various platforms as of 2012, they would all talk directly to the OneBusAway server at University of Washington, and then pull back information that was related to the Puget Sound area and Seattle area of Washington State. So one option to expand these apps to new cities, because we do have access to the underlying software for the applications, is simply to copy and then rebrand the applications for each of the new cities. So this diagram shows how that would look, where you have a OneBusAway for Puget Sound, OneBusAway Tampa, OneBusAway Atlanta. Each of these would be separate apps in the app stores that are rebranded per city. And then also on the server side, we have these individual OneBusAway servers, which are set up in each of these areas of Puget Sound, Tampa, and Atlanta. Excuse me. The downside of this approach is that since one of the issues that we're dealing with is that there just isn't expertise in certain cities to develop and maintain mobile apps, we still have this issue of now, while we have a source code base to start with, copying them also creates maintenance work for each city per platform. So anytime there's an update released for an application or an improvement or a new feature, somebody for each of these cities has to go through and copy and merge the improvements and then redeploy the app to the app stores, to the various platform app stores. And when you're dealing with 4 different platforms, that's really a lot of work. And if this is an issue to start with, we really don't want to go down this path because it's going to continue to be an issue. This also clutters app stores. So while having 3 different regions may be somewhat acceptable to have 3 different OneBusAway apps in each app store, but as this scales up and say we now support 50 different cities, to have 50 different OneBusAway apps in the app store. So for iPhone, for example, when you went to download OneBusAway and then you have to choose from 50 different OneBusAway apps, it just doesn't scale very well at all, and it creates a confusing experience for transit riders. And it also fragments the source code. So if everyone's copying the source code for their particular city and maybe making tweaks and changes, it makes it really difficult to maintain a really solid set of code for each application that is quickly updatable and to make sure everyone's on the same page with features and everything like that. So we want to try to avoid this type of design if possible. So we came up for a solution to this with the Multiregion Design. And in this design, each region maintains its own OneBusAway software server, but uses the same set of mobile applications. So this design reduces the burden on each region to maintain the apps. And the reason behind this is because the same app actually works across all the different regions or cities that are added to the OneBusAway ecosystem. This also eliminates the burden on a centralized entity to maintain data quality control, servers, and customer support for each new region. So for example, since the original OneBusAway instance was hosted at the University of Washington, we could ask the University of Washington to add data and servers and infrastructure to support Tampa and then Atlanta and then each new city that came along. But that quickly becomes a burden on the University of Washington to maintain both the infrastructure and the personnel to really make sure the entire system is working well. And then the other benefit of this is that it doesn't clutter the app stores. The users just have a single OneBusAway app to download, and then that automatically works across all the different regions that are added to OneBusAway. So you can kind of sum this up in the single slogan: you bring the server and we bring the apps. So again, trying to solve the problem of how do we get rapidly expand mobile transit apps to new cities. And the answer is we already have the apps. It's just a matter of sharing the software that runs the server for each region, and then it's just a matter of the region setting up their own server, and then the apps can automatically work with that. So this is what it looks like from a technical perspective, this multi-region architecture. We have now the centralized server directory, which is behind this regions API. So each time we add a new server, we just add a new entry in this server directory. And each of the mobile apps for iPhone, Android, Windows Phone, and Windows 8, as part of this project, they were all modified to instead of just directly connecting to a OneBusAway server, now they check this regions API, which has a list of all the available OneBusAway regions. The app automatically determines the closest region to its current real-time location, and then connects to that particular OneBusAway region. So, for example, if a user was to open up the OneBusAway app in Tampa, they would see Tampa transit information. If they open up the same app in Puget Sound, they say Puget Sound information, and same for Atlanta and any other regions that are added to the OneBusAway system. So this is what the actual server directory looks like. Again, in the spirit of keeping things low cost and also reducing the amount of code that we actually have to write to maintain this system. We're just using a simple Google Docs spreadsheet as the container for the information. And then we dump this out into a format that's a little more compatible for the mobile apps to consume. But you can see here the different records and entry. There's the different web addresses that each of the apps talks to the servers at. And this is essentially the core information that each mobile app has access to. So it knows which OneBusAway region is available and the closest region to the user's current location. So adding a new server at this point, a new OneBusAway region, is really as simple as just that region setting up their new OneBusAway server and then adding a record to the spreadsheet here. And in a close-up for the user experience of the OneBusAway application, when the user fires up this is the OneBusAway Android app, the app is able to immediately identify their current location using GPS or another location technology, and then automatically retrieves the bus stops that are currently near that user. And there's some other features like searching for particular stops and routes. What the user is able to do then is if they want to find out, for example, what time is the bus going to arrive at this bus stop that's near them, they can tap on that and then tap Show Arrivals, and they'll see a list of the different buses that are scheduled to arrive, or I'm sorry, this is the real-time information for when the buses can be expected to arrive at that particular stop. In this example, we see a Route 5 that's going north to University Area Transit Center, and that's arriving right now, and that's running 1 minute late. And similarly, we have another Route 5 going the same direction. The next one's going to be in 32 minutes. That one's currently running 3 minutes late, and then we have another after that that's running 4 minutes early. The natural question that comes next is, well, what are the actual steps if a transit agency or another individual organization wants to set up a new OneBusAway region? How do you actually do that? So this is a checklist that we put together that you can go through to guide you along the way starting from just transit data to actually launching the new apps in your city. The first step here is, as I mentioned earlier, is transit data in the GTFS, or General Transit Feed Specification format. There are many different agencies that have their data in this format already. This is the same format that Google Maps uses for the Google transit directions, and is used by many other transit applications as well. And I think last I checked, there's over 200 U.S. agencies that that have their data in GTFS format. The next checklist item here is an AVL system that provides you some type of arrival estimate. So how early or late is the bus going to be? The third item here is to implement we recommend either a GTFS real-time or a SIRI data feed. SIRI is another real-time format. GTFS real-time is a format for real-time application that's a counterpart to the GTFS format, which is for scheduled data. And OneBusAway actually supports a few other formats as well. These seem to be the two most widely accepted formats, GTFS real-time and SIRI at the moment. So if you don't have your data in these formats, you can either develop a converter or work with your AVL vendor to implement one of these feeds, or you can look at some of the other formats that OneBusAway supports. And then the fourth step here is to actually set up a OneBusAway server, and again, the source code for this is all open and available on GitHub, a code hosting site. So it's freely available for anyone to go and download and set it and get it up and running. And then there's a good set of instructions online that will guide you step by step on how to do that. We also recommend you do some quality control testing to make sure that the arrival times that you're showing to users are actually accurate and match what the transit rider is experiencing on the ground as they actually wait for the bus. And then the final step here is to actually launch OneBusAway apps in the new city. So once you have your OneBusAway server set up, you just send a request to the OneBusAway developers group, and we'll add you to the multi-region setup. So in adding a new region to the OneBusAway apps, we currently have two different stages that we're working on. So once the request is made, we'll add regions first as experimental regions. So this means the region is still somewhat in development. This is a way to quickly onboard new servers without significantly disrupting the current user experience in cities that have been running OneBusAway for a while. So users can see experimental servers or experimental regions in the iPhone and Android apps by simply enabling a setting inside the app to enable experimental regions. And this allows us to test and make sure that everything's working right within an experimental region before we move to the next stage. The second stage for a region is full productions, and this is the state that Puget Sound, Tampa, and Atlanta are currently in. And for a production region, this meets a certain standard in terms of the quality and quantity of real-time data. And the reason why we want to make sure there's some kind of standard here is to protect the OneBusAway brand and make sure that users have if they're promised a OneBusAway experience, that they're happy with what they see and want to leave positive reviews on the app stores. So that this is just some basic guidance to regions for what they should expect to provide to users to be a production region. And when you're a production region, this means the region's available on all apps by default. So as soon as the user downloads an app on any of the 4 platforms, they'll automatically be connected to the region in their particular area. And we've outlined these standards online here in this particular post if you're interested, and I can, if anyone's interested in the details, I can go into that as well with them. As a particular use case in this multi-region project, one of the pilot regions that we tested this with was in Tampa, where USF is located in Tampa, Florida. So what I'm going to talk about here briefly is the OneBusAway Tampa experience of us setting up a new OneBusAway server here in Tampa. So we started with both in transit data in the GTFS format. Hillsborough Area Regional Transit, or HART, here in Tampa already had their data in GTFS format, and they already had an AVL system that provided arrival estimates. But at the time, that was only internal facing for operations purposes. It wasn't information wasn't being shared with transit riders. So that really left these last 4 steps for us to complete to launch OneBusAway in Tampa. So again, this is HART's AVL system. So they already had an OrbCAD AVL system for tracking their buses, which produced arrival times, and they had the data available in a Microsoft SQL Server database. So we developed a GTFS real-time converter that took in the information from the OrbCAD SQL Server database and then formatted that according to the GTFS real-time format. And if anyone's interested in the actual software to do that, we made that available as open source on GitHub as well. And the second step here then is to set up our own OneBusAway server, which we again did here at USF. And then that OneBusAway server consumes the information produced by the GTFS real-time feed. And then each of the apps connects to this OneBusAway server to retrieve the smaller bits of transit information, such as what are the bus stops closest to a rider's particular location. And just to give you an idea what the GTFS real-time format looks like in plain text, at least, the actual format consumed by the applications is in a binary format, which makes it much smaller and more efficient. But this is what it looks like in plain text as you're working on a feed and looking at the data. So we have things like a trip ID, which ties back to the trip ID and the scheduled GTFS data, and that refers to how a particular bus is going to visit a sequence of stops for a particular route. And then in the real-time information, we see things like the arrival time and a delay of negative 180. So this is meaning, and this is seconds, so this is meaning that the bus is running 3 minutes fast as opposed to 3 minutes late. And then we know the particular stop ID that this bus is serving right now, and then the sequence of stops of where this is in the particular trip. So we're at the 17th stop for this particular trip sequence. And we also have an identifier for the vehicle. And this data, which we'll see in a second, is actually the data, especially the delay value here is what's seen in the mobile applications. The other thing that we have is vehicle position. So this is more the latitude and longitude information of where the bus is in real time. This information isn't currently shown in the OneBusAway mobile applications, but that's something on our roadmap to implement in the future. So back to the mobile application and the real time when a user pulls up information related to a stop near them. We can see that delay value. So this is the same value that was shown in the GTFS real-time feed. So we see that 3-minute delay here. 3-minute delay. And then we also are showing on the right-hand side the arrival estimate. So based on that real-time delay, how long is it going to be until my bus arrives? In this case, it's 32 minutes. Normally that would have been 29 minutes if we didn't have real-time information. So this tells the user they have an extra 3 minutes more than what you would usually have before this bus arrives. Some of the general challenges that we encountered that we think are probably applicable to others, and we wanted to share. I'll talk a little bit about that on this in the next slide. So one that was actually unique to us was that at the time that we started, some of the documentation for the OneBusAway open source project was fairly dated. So we worked on creating some new documentation as we went to make sure that it was there was a set of step-by-step instructions for somebody who wasn't familiar with the project to come in and set up their own OneBusAway server. And this, it takes some time, but we've already seen some other regions like Atlanta and others benefit from this. And as new users come along and keep setting up OneBusAway servers, others have contributed to the documentation as well to make sure that it's clear and easy to understand to reduce the learning curve of setting up a new server. We also, when we started in Tampa, didn't really know the accuracy of arrival times that were being produced by the AVL system. And I'll talk about this a little more in the next slide. What we ended up doing for this was on-the-ground testing and validation of actually going into the field and pulling up the mobile app and seeing when the bus was going to arrive and see how that compared to the estimates that were being provided to riders. And again, you want to do this to make sure that when you're promising riders real-time information, we want to make sure that riders can trust the information that we're giving to them. So if we tell a user that their bus is 3 minutes late, and it's actually 3 minutes early, that's not a good thing, and they're going to miss their bus. And we want to make transit riders' lives easier, not harder. Also, just the communication with the various parties that were involved in this project, from the agency ITS staff, which was different from the agency IT staff, and then agency marketing. We're talking about launch, and then working for the vendor for the AVL system. There are just a lot of parties involved that all had responsibilities over different parts of the system. We found it really important to get upper management buy-in from the agency, including in-person meetings, and then also identifying a champion within the agency, or a single point of contact that we could go to talk about any issues that were going on, make sure everything was running smoothly. And a big shout out to Shannon Haney from Hart, who was our champion at Hart here in Tampa, and he did a great job of pulling everything together and making sure that, that any issues that were going on, we were able to get addressed. So some of the data challenges, which I think you may not encounter all of these when you're working with data in a new mobile applications, a set of mobile applications like OneBusAway, but you may encounter some of them. Typically, everyone's data has issues. You just don't know the issues exist until you start putting a spotlight on the data. And that's, when you start actually sharing that data with writers and getting feedback from them. So we saw a variety of things, such as in the GTFS or the schedule data. There was things like arrival time for stop A was after arrival time for stop B during the trip, even though stop A occurred before stop B. So there's some things that just logically didn't make sense. Hart was originally missing seconds resolution in the GTFS feed, so they just had hours and minutes. And then some incorrect route URLs. So OneBusAway allows writers to drill down further to an actual scheduled information that's on the agency's website, for example, if they want kind of longer schedule that's more drawn out for a longer period of time. So we worked with Hart, and Hart was great about resolving these issues as they came up. And we just made sure to provide them plenty of information and documentation showing what the issue was and how we thought it could be fixed. One of the challenges we had when looking at the real-time data was initially the trip IDs that were being produced by the AVL system did not match the same trip IDs that we saw in the GTFS data and the schedule data. And from talking with others, this seems to be a common issue where a lot of the times the AVL vendor may not be the same vendor that the agency is using to produce the schedule information or being used to produce the GTFS data. So this really requires some type of way to tie the two, both the GTFS schedule data to the real-time data. And so we were able to do that by talking with the AVL vendor and talking directly with them to help figure this out. And we were able to pull a different trip ID from the database that actually did match the GTFS trip ID. One of the other issues which confused us for a little while is that the AVL system had a opposite interpretation of plus and minus for delay values. So typically with the GTFS real-time and other systems, we see delay is represented as positive values, and running ahead of time is represented as negative. We actually saw that flipped inside the agency's database, and it took us a little while to figure out that was one of the problems we were seeing. And again, communicating directly with the vendor and being able to ask questions really helped in that situation. There were some SQL Server replication issues that we worked with the agency and the vendor to address as well. And we also had a choice between two different values when we pulled from the database to create the GTFS real-time feed. One was called deviation, and the other was predicted deviation. And again, just kind of on-the-ground testing to figure out which one was going to work better for the information we were showing to writers for how long it was going to be until their bus arrived. It just took some on-the-ground testing to make sure that we were choosing the right value here. So I think just working through the data, communication, and open communication with both the agency and the vendor and any other parties that are involved are really the takeaways here for how to address these and related issues. So in Tampa, we went from a pilot to production in 2013. We originally, USF launched the pilot of OneBusAway in Tampa with approximately 200 users in February of 2013. We partnered with Georgia Tech to do a controlled study of the impact of real-time information on transit riders. So we had about 200 users that didn't have access to OneBusAway, and then 200 that did. And we wanted to understand how that affected their perception of transit and wait times and that type of thing. So we have some results to share, and maybe that'll be as part of another CUTR webinar in the future. We also maintain the OneBusAway server software and the GTFS real-time feed here at USF for the pilot project. And Hart kind of looked at this as a pilot too to see if they wanted to proceed with OneBusAway as for their own customer-facing real-time system. And the pilot went great. Everybody was really happy with it. Riders loved it, and Hart thought it was great. So we actually did a public launch to all of the city of Tampa and Hart's ridership in August of 2013. And so Hart, at that point, Hart adopted OneBusAway Tampa for the production instance and the public launch, and it's running on their infrastructure and servers as of the right before the public launch. And we assisted Hart in preparing an RFP to secure some long-term vendor support. And that was successfully completed in February of 2014. So there are definitely some options out there for vendor support. In Hart's case, it was Cambridge Systematics. So if an agency doesn't necessarily have the in-house expertise to run OneBusAway, we can definitely refer you to some of the agencies that have worked with external partners to make it happen. So the takeaway here, some of the lessons learned in general for the multi-region project and conclusions. Open source software really enabled this project. There were many contributors, as I mentioned earlier, some individuals that just contributed software modifications on their own time. Paul Watts and Mike Broad both contributed to the Android and Windows Phone, Windows 8 apps. And just a number of other contributors. And this was really only possible because everyone could access a copy of the source code, make some modifications, and then contribute those changes back to the central project. So we see this as a huge enabler where previously developers were just working in their own cities. So the developer that lived in San Francisco would be developing primarily apps that ran in San Francisco on that particular transit system. But now we're able to leverage the same software code base for a number of developers that live all around the world. So here in Tampa, I was able to contribute to the OneBusAway Android application, and those contributions, as well as the software that everyone else wrote, is now running in the Puget Sound area, Atlanta, Tampa, and other locations as well. And then GitHub being a code hosting site where the OneBusAway software is stored really enables sharing and merging of code in the Git versioning system. The project really wouldn't have been possible without all these different tools in the open source ecosystem. Something else that we learned too is that volunteer developers are great for general advancements of the project, but for certain time-sensitive or specific tasks, paid developers may be required. So this is if you're trying to meet a particular deadline, like getting for a production release of a new feature in an app, for example, or something else that may not, for someone who's contributing of their own free time, may not be of interest or within their capabilities to take on. You may want to look at some contract software developers as well. Also, we've learned that identifying an ongoing funding source is important for the limited centralized operations that do occur. For example, when a developer wants to contribute an improvement to, let's say, the OneBusAway Android app, they can submit that improvement back to the OneBusAway community to review and possibly merge to be made available to all the different OneBusAway cities. But there still needs to be somebody to review and actually merge that software and make sure that everything's running. So while there isn't a huge amount of work that needs to take place centrally, there are some core functions that we're currently working on identifying a funding source to assist with some of those. There's also we're also seeing a pattern of this tech demo to production region deployment process. So both at University of Washington started the OneBusAway instance there, and USF started the OneBusAway instance here in Tampa, Florida. And in both of those cities, the Puget Sound Transit took over the instance and adopted the instance from University of Washington, and Hart adopted it from us. So we're seeing this pattern of independent developers, and Kurt Raschke has done a great job of setting up an instance in Washington, D.C. that's currently a tech demo there, and along with the mobility lab that's doing the hosting. And we'd like to see more of these independent transit developers just throwing up a demo for their city and then trying to show it to the different transit agencies and other stakeholders. And what we've seen so far is that the agencies see great value in it for themselves and the riders, and it's a very cost-effective solution. And then often these agencies then adopt the actual OneBusAway instance and start running it themselves. So our general conclusions here are the output of the OneBusAway multi-region project. We now have OneBusAway apps in many new cities outside of the original Puget Sound deployment. So we have OneBusAway in Tampa and Atlanta as full production deployments, and Georgia Tech worked with MARTA for the Atlanta deployment. We also have the Washington, D.C. instance I just mentioned, which is a tech demo. And we just recently added York Region Transit in the York region in Canada, and that's also currently in the tech demo state as well. And we hope to see those promoted very soon to full production status, so users can just open up the apps in DC and New York and instantly get access to transit information in those cities. And this general OneBusAway multi-region architecture that we've created, it makes it really easy to add new cities in the future. It's a sustainable, scalable, low-cost, and low-maintenance model where each of the regions is really responsible for their own real-time data and their own OneBusAway server. Then they're able to take advantage of these applications, which are available across all the different cities without having to actually maintain the applications themselves. This is a screenshot of the new OneBusAway.org, www.onebusaway.org homepage, and you see the new multi-region aspect of OneBusAway reflected with the various production regions in the drop down here. I also didn't mention earlier that New York also used the OneBusAway software system, MTA, to produce their bus time system in New York City. So that's was also one of the huge deployments leveraging the OneBusAway software. So some of the future work that we expect to occur in the very near future is we want to continue ongoing research to understand the impact of real-time information on riders. It really helps us understand what users want and what can really impact them positively in terms of their transit experience, and also how to encourage the use of non-single occupancy vehicle modes. If we're able to really reduce the learning curve for not driving alone, so enabling people to use transit and car share and bike share and all these different modes that are available, we really are very interested in that, and we think OneBusAway plays a huge part in that. And then secondly, a lot of this research really helps to justify investments in the technology. Often agencies are looking for hard numbers to say, to justify to their own board or management to say, if we install real-time systems, this is what we expect to happen for the riders and for ourselves. And a lot of this research really provides the agencies hard numbers that they can refer to and show the benefits of real-time technology. Some of the new features that we expect in the very near future are improved issue reporting of communicating various problems with transit infrastructure, such as broken benches or other issues back to the agency. We expect to see continued contributions from deployments and individual developers. I've also been personally working on OneBusAway for Google Glass, which we hope to see used more widely soon. And then there's other things on the frontier as well. So the full acknowledgements for the OneBusAway multi-region project are at the URL shown here. Again, there's a huge number of partners in this, and they all deserve acknowledgements for their contributions to the project. The funding for USF's portion of this project was provided by the National Center for Transit Research. We'd like to thank Hillsborough Regional Transit, or HART, for both giving us access to the real-time data for the OneBusAway deployment and their support of OneBusAway and the public launch of OneBusAway in Tampa. And again, as I mentioned, University of Washington and Georgia Tech continue to be involved and do various work with the OneBusAway project. And again, just to thank all the OneBusAway community members, both the individual developers and organizations that help OneBusAway be as successful as it is. So with that, I think I will turn it back over to Julie, and I'd be happy to answer any questions.
Okay, well, great job, Sean. That was a very informative presentation, and I'm sure everyone enjoyed it. And we do have questions coming in. Again, as you can see on the screen, if you'd like to ask a question, simply click on your Q&A manager and type your question in, and I will moderate those to Sean. So, Sean, your first question is, what is more valuable to the traveler, the estimated arrival time of the bus at the bus stop, or the actual location of the bus relative to the bus stop?
That's an excellent question, and that's something that we've been talking about recently. We think that the estimated arrival time, assuming that the arrival time itself is accurate, requires a little less thought on the part of the passenger. So just, if my bus is 10 minutes away, I know I have 10 minutes to do something. And that also seems to be more useful to transit riders that aren't that are new to the system. So they may not know what the typical traffic is for a road, which when all you have is the location of the bus, I think you have to do a little more thought on your own and may require a little bit more knowledge of where the bus is and the typical traffic is expected to encounter, that type of thing, to really turn that into how much time do I have until that vehicle arrives. So we're going to continue to do more work. Our goal is really to provide both to transit riders and let them choose which is more useful to them for their particular situation.
Okay, great. The next question, is it possible that OBA can assign or identify the trip based on the only bus that could be displayed at that location and that time versus matching up the trip ID, and then which deviation method worked best for Tampa?
The answer is yes, some type of matching is possible. In MTA in New York, some of their work with OneBusAway, they're doing something similar where they're actually inferring which trip the bus is currently assigned to. I think there's still room for more work in that area. The question is, are you dealing just with position, or do you have position plus, for example, bus operator login or something like that? I think the more information you have, the easier it is to infer those types of things. We were fortunate in Tampa that we didn't really have to deal with that issue, and we were able to pull trip IDs that match GTFS real-time directly out of the AVL system. So in our case, we had a one-to-one match that we could just instantly apply a real-time update to a particular trip, and we knew that the delay was referencing that trip.
Okay, great. Okay, another attendee says, thank you for making this open source. What value is it for transit agencies? And can you see how this could have an application for demand response services, given that demand response services have to date not been expressed in GTFS real-time that I know of?
Yes. So I think the value to agencies, we're hoping to pull a little more information together. And I know Carrie Watkins at Georgia Tech, I believe, is currently working on a paper with some of her team to look more at the cost-benefit area of this. So we believe it's more cost-effective than some of the alternatives for implementing your own apps, for example. And if you're looking to reach all the different platforms and provide many of the features that OneBusAway does, I think there's also a compelling argument that it's more effective than many of the proprietary vendor products that are out there. But we hope to have more information on that soon. So please contact me and we can get you more information when it becomes available. In terms of demand response, there are some efforts to add or define demand response for GTFS going on right now. I think something like vehicle positions for transit demand riders would definitely be useful, and that's something that we've talked about in OneBusAway, and hopefully we may be able to provide something like that in the future.
Okay, great. Okay, the next question, can you explain how OneBusAway differs from Google Transit?
Sure. So Google Maps or transit information in Google Maps today is primarily in a trip planning context. So you want to know how to get from point A to point B using public transportation. And then Google Maps shows, based on the real-time information, how your trip may change based on the real-time information and delayed or early buses. OneBusAway is designed primarily for the the quick, I know where I'm going. Today we don't have, as of today, we don't have trip planning on OneBusAway, although it's something that we do have on the roadmap for the future. But it's that quick, I want to know how long is it going to be until my bus arrives. So the daily riders primarily that want to optimize their trips and their travel for a particular, for every day when they use the bus system. So, and then we also have the open source nature, obviously of the project, where you can ask Google to add a new system, but they may or may not add it. And so one example for this is the Bullrunner here at USF. That doesn't exist in Google Maps or with Google, but we can set up our own OneBusAway instance here in Tampa, and it's something we're working on to provide information for that system. So it's within the control of the community and agencies and individuals to actually set up the information system themselves.
Okay, great. Another one, is there an API available or plans for it to provide access to the OBA data so apps outside the OBA app can be enabled?
Yes, definitely. There is a set of APIs that's available. There's the original set of APIs, which exists from the early days, and there is some work that MTA primarily has done, and I know Kurt and others have been working on a Siri-based API for mobile apps that's currently functional and what MTA is using in New York. We'd like to make that available in other cities. But yeah, there's definitely multiple ways to pull the information out of OneBusAway, and OneBusAway by default supports things like API keys. So if you want to set up OneBusAway in your city and make it available to all kinds of application developers to develop new apps beyond the ones that are already available, that definitely exists, and we would encourage you to do that.
Okay, let's see another one. Will you be able to purchase the ticket from this application for the bus in the future?
That would definitely be great, and something we would definitely be interested in. I think there are a set of questions, and it all depends, I think, on the agency's choice of vendors used for the payment system. But assuming, provided that a vendor would be interested in working with us, I think we would definitely be interested in pursuing that as a OneBusAway feature.
Okay, great. Another question, can this be used with Uber car or other modes in the future?
Yes, we definitely like to make OneBusAway a one-stop shop for all kinds of multimodal information. So again, because of the open nature of the system and the access to APIs, and we're able to pull information from other systems in as well, we definitely would love to have something like that.
Okay, great. Okay, another question. Has any of the research determined impacts on attraction and retention arising from real-time info availability?
Off the top of my head, I want to say I don't know of any, but if you want to contact me directly, I'd be happy to connect you with Carrie and some of the others that have been more directly looking at it and involved in the various research that's going on in that area.
Okay, great. Looks like we just have a couple more questions, Sean, and time is almost out, so let me go through a couple more. How is this app more beneficial to users than other similar apps that have been around for years?
So I think it really depends on your city, and it depends on what types of apps are already available. So for example, in San Francisco, where there's a number of transit apps that have been around for a while, the benefit of OneBusAway may not be as great as in a new city like Tampa, where just no information and no apps existed. Then obviously, it's a really cost-effective method to bootstrap real-time transit information on apps in a new community. I think the fact that we've in the past just had these information systems for transit siloed per city, OneBusAway offers an opportunity for everybody to be working on the same project. So instead of a developer in Miami working on a feature that's just used in Miami, if you implement that same feature in OneBusAway, it's going to be available not just in, say, Miami, if there's a OneBusAway deployment there, but all the other cities as well. So we see this as a community project where we could really very quickly enable the spread of new features and new applications to a lot of different cities very quickly and very cost effectively, and within the control of the agency or others. With third-party applications and other vendors, they could go bankrupt tomorrow and shut down their service. A good example of this is when iOS and Apple removed Google Maps from their phones. iPhone users lost transit directions for a while, and there was really nothing that could be done for iPhone users at that point, except for start searching for other applications. So we think it's a very cost-effective way to make transit apps available in new places.
Okay, great. Well, Sean, it looks like we're out of time. You had a very interested audience there, lots of questions, so I know they found your presentation very interesting. But before you leave, please take a few minutes to fill out the evaluation that you can see on your screen. This helps us evaluate our presentation, and then you can give us ideas for future webinars. And so please take the time to fill that out. It's very short. It will just take you a couple minutes. So again, Sean, thank you very much. Great presentation. And we look forward to seeing everyone at the next CUTR webinar. Have a great day.